A thriving koi pond is a breathtaking addition to any landscape, yet the health of your vibrant fish and the clarity of the water hinges on one critical component, a good filter. Far from a simple box, the right filtration system is the life support for your aquatic ecosystem, tirelessly removing debris and converting harmful waste into harmless nitrates. With a variety of options, from advanced drum and nexus filters to natural bog systems and traditional multi-stage units, selecting the optimal setup can feel overwhelming. Understanding the balance between mechanical, biological, and UV filtration is the key to maintaining that crystal clear water and a stress-free environment your koi deserve. The role of filtration in a healthy koi pond ecosystem. Filtration is not merely about keeping the water clear. It is the absolute foundation of a healthy, balanced koi pond ecosystem, serving as the system's vital life support. The constant process of water treatment is what allows a high bioload environment, like a pond housing large koi, to remain stable and stress-free for its inhabitants. An effective filtration system works in a three-pronged approach, mechanical, biological, and UV, to manage both physical debris and invisible toxic waste products. The first line of defense is mechanical filtration, which acts like the pond's vacuum cleaner. This stage physically separates and removes solids, such as uneaten food, fish waste, and plant debris, from the water column before they can decompose and pollute the system. Removing this debris prevents the buildup of sludge and maintains the crystal clarity essential for viewing your fish. The most critical function, however, lies in biological filtration. Koi naturally produce ammonia, a compound that is highly toxic to fish as a waste product. The biological filter media provides a massive surface area for colonies of beneficial bacteria to colonize. These bacteria tirelessly convert the toxic ammonia into less harmful nitrite, and then further convert the nitrite into the much safer compound nitrate, which can then be absorbed by aquatic plants or removed through partial water changes. This process, known as the nitrogen cycle, is indispensable for a healthier habitat and eliminating harmful compounds that could otherwise lead to fish illness and death. Finally, a UV sterilizer provides a final polish to the ecosystem. It targets free-floating single-celled algae, which cause the water to turn green, as well as certain waterborne pathogens. By disrupting their DNA, the UV unit clumps the algae, making them easier for the mechanical filter to trap and remove. Therefore, the combination of a mechanical stage for clarity, a biological stage for water quality, and a UV stage for aesthetics ensures a stable, visually stunning, and ultimately sustainable environment for your koi. Understanding the three pillars of filtration: mechanical, biological, and chemical. A truly effective koi pond filtration system operates on the principle of synergy, relying on three distinct and crucial pillars: mechanical, biological, and chemical filtration. While the provided context already highlights the indispensable nature of the biological stage, all three elements must work in concert to achieve optimal water quality and clarity. The journey to pristine water begins with mechanical filtration, which serves as the pond's first line of defense. Its primary function is the physical removal of solid debris, such as fish waste, uneaten food, and leaves. This stage is critical for maintaining water clarity and protecting the subsequent stages. Modern koi ponds often utilize highly efficient systems like sieve filters and rotating drum filters (RDFs), which employ fine screens to remove particles as small as 200 to 300 microns. By removing this larger organic matter, mechanical filtration prevents it from reaching and clogging the biological media, ensuring that the beneficial bacteria can perform their life-sustaining work without obstruction. The second pillar, biological filtration, is the heart of the system, responsible for the chemical stability of the water. As you know, this stage provides a vast surface area for the colonization of beneficial bacteria, which tirelessly execute the nitrogen cycle, converting toxic ammonia and nitrite into the safer nitrate. Finally, chemical filtration acts as a powerful supplement, offering a targeted solution for impurities that the first two stages cannot address.
This pillar focuses on removing dissolved organic and inorganic compounds, a process often unnecessary for a well-maintained pond, but invaluable when water quality issues arise. The most common media used is activated carbon, a highly porous substance that excels at absorbing specific impurities, controlling water chemistry, removing dissolved yellowing compounds, and neutralizing residual medications. When combined, these three pillars ensure the pond water is not only visibly clear, but also chemically stable, supporting a thriving and healthy environment for your koi. Choosing the right filter architecture, pump-fed versus gravity-fed systems. The foundational decision in designing a robust filtration system for a koi pond is choosing between a pump-fed and a gravity-fed architecture. These two approaches dictate the system's layout, maintenance, and ultimate debris handling efficiency. Pump-fed systems are the most common and easiest to install, making them popular for new or smaller ponds.
In this design, a submersible pump is placed directly in the pond, drawing water and forcing it uphill through the filter unit before it gravity flows back into the pond. This simplicity translates to a lower initial cost and a setup that doesn't require complex plumbing below the pond's water level. However, a significant drawback is that the impeller of the pump can mince large debris, like koi waste and leaves, into finer particles. These finer solids are then harder for the mechanical filtration stage to capture, potentially leading to increased organic load and more frequent maintenance of the filter media itself. Gravity-fed systems, conversely, are the preferred architecture for high-quality koi ponds, especially those with bottom drains. In this setup, the filter sits level with or below the pond's waterline. Gravity draws water directly from the pond, typically through a bottom drain, into the filter's inlet. After the water has passed through the mechanical and biological stages, an external pump is used to return the purified water back to the pond. This is considered a low-pressure system because the pump is post-filter, meaning it handles clean water, which is more efficient. Crucially, because the debris bypasses the pump, it arrives at the mechanical filter intact, allowing for superior and more efficient solids removal. While more complex to install, requiring the filter to be sunk into the ground or housed in a separate structure, a gravity-fed system offers lower maintenance and higher long-term efficiency for managing the heavy waste load produced by koi. The choice hinges on a critical trade-off: ease of installation versus efficiency. If simplicity and budget are paramount, a pump-fed system may suffice. However, for serious koi keepers aiming for the clearest water and healthiest environment, a gravity-fed system with a bottom drain provides the superior high-performance foundation for the filtration pillars. A deep dive into popular koi pond filter types: drum filters, nexus, and pressure filters. The pursuit of pristine koi pond water has driven the development of highly specialized filtration technologies, with three main types dominating the high-performance landscape: drum filters, nexus systems, and pressure filters. Drum filters, DFs, represent the pinnacle of automated mechanical filtration. Unlike conventional methods, a rotary drum filter uses a fine mesh screen drum to sieve out even the smallest solid waste particles, often down to 70 microns. As the mesh clogs, an automated sensor triggers a cleaning cycle, spraying backwash water onto the rotating drum and flushing the debris out. This high-efficiency automatic solids removal is unparalleled, leading to significantly reduced maintenance and a lighter load on subsequent biological filtration stages. However, DFs are exclusively mechanical. They must be paired with a separate biological filter unit to complete the necessary nitrogen cycle. The Nexus system, such as the Evolution Aqua models, offers a popular all-in-one solution for koi keepers. It cleverly combines both mechanical and biological filtration within a single compact unit. The inner, easy chamber provides mechanical filtration, while the outer chamber houses a substantial amount of K1 or K+ media, providing a vast surface area for beneficial bacteria to colonize for the biological stage. Nexus filters are highly effective, easy to clean via a simple air scour process, and provide a strong balance of performance and maintenance simplicity. In contrast,
Pressure filters are typically sealed, closed-system canisters where pond water is forced through the media under pressure. They are favored for their ability to return water to a height above the filter, making them ideal for small ponds with waterfalls or higher features. Pressure filters often combine sponge-based mechanical media with biomedia and a built-in UV sterilizer. While simple to install in pump-fed systems, their mechanical filtration capacity is limited and requires frequent manual backwashing to manage the heavy waste produced by koi, often making them less suitable for large or heavily stocked ponds.
For serious koi enthusiasts, the power and automation of a drum filter or the robust balance of a Nexus filter are generally the preferred higher efficiency choices. Essential koi pond filter media explained: Caldness K1, Japanese matting, and ceramic media. Effective filtration relies heavily on the media housed within the filter chamber, which provides the critical surface area for biological colonization and mechanical debris capture. While filter types like the Nexus dictate the overall system, the choice of media directly impacts the efficiency of the nitrification cycle. Caldness K1 media stands out as a high-performance biological media, popularized by the moving bed technology in filters like the Nexus. Its unique wheel-shaped design is engineered to create a large protected surface area for beneficial bacteria to colonize. Unlike static media, the K1 tumbles freely and chaotically within the filter chamber, constantly shedding older, less efficient bacteria and waste. This self-cleaning action ensures that only the strongest, most active biofilm remains, making it exceptionally efficient at converting harmful ammonia and nitrite. K1 is chemically inert and, because it moves, does not require manual cleaning, making it a cornerstone of low-maintenance, high-efficiency biological filtration. For a robust, traditional option, Japanese matting remains a highly favored and versatile media. This specialized fibrous mat is known for its incredible durability and an open, three-dimensional structure that offers a high usable surface area for biological bacteria. The rigidity and density of the matting also make it an effective mechanical filter, trapping large and medium-sized debris before it can clog the finer biological stages. An added practical advantage is its convenient customization, as the sheets can be easily cut to fit precisely into most filter designs, including multi-bay systems. Finally, ceramic media, often in the form of highly porous rings, spheres, or noodles, excels purely as a biological filter. These fired, inert materials are defined by their extreme porosity, which drastically increases the internal surface area available for bacteria colonization. A single piece of ceramic media can host a greater volume of beneficial bacteria than non-porous media of the same size, dramatically boosting the nitrification capacity of a static filter stage. While primarily biological, certain dense, porous ceramic materials can also contribute to mechanical filtration by trapping fine particulates in their rough texture. Sizing your filter: pond volume, fish load, and water flow rate calculations. Selecting the correct koi pond filter is fundamentally a mathematical exercise, requiring a precise calculation of three interdependent factors: pond volume, fish load, and desired water flow rate. Miscalculating any one of these can lead to an undersized filter, resulting in poor water quality and an unhealthy environment for your koi. The first step is determining your pond volume. For rectangular or square ponds, a simple calculation can be used: length, feet, times width, feet, times average depth, feet, times 7.48 equals volume in US gallons. Knowing the total volume is essential because it dictates the minimum filtration capacity needed to maintain clear and healthy water. Next, you must establish the necessary water flow rate. A robust koi pond demands high water turnover, with the industry standard recommending that the entire volume of the pond should pass through the filter once every hour. This means a 3,000-gallon pond requires a pump and filter rated to handle at least 3,000 gallons per hour. However, a critical design choice is oversizing the filter and pump, which ensures the system can cope with reduced flow due to head loss, dirty pre-filters, and an increased biological load. The final and perhaps most crucial factor is the fish load. Koi are known as dirty fish due to their substantial waste production, which significantly elevates the organic and ammonia load on the filter's biological stage. General guidelines suggest one 6-inch koi for every 100 gallons of water, but this estimate should be conservatively applied. Since koi grow large and produce a high concentration of waste, it is vital to select a filter that is rated for a volume significantly larger, often 1.5 to 2 times the actual pond volume, to effectively manage the heavy nutrient cycling required. A filter rated for a 6,000-gallon pond, for instance, is often the proper choice for a heavily stocked 3,000-gallon koi pond. The importance of UV clarification in combating green water and algae. While the mechanical and biological stages of a filter are essential for removing solid waste and processing ammonia and nitrite, they do not provide a complete defense against a common and persistent issue in koi ponds: the proliferation of single-celled, free-floating algae. These microscopic organisms are the cause of the unsightly green water that can quickly turn a crystal-clear pond into an opaque pea soup environment, which is especially problematic in heavily stocked koi ponds where the high nutrient load acts as a constant fertilizer. This is where an ultraviolet UV clarifier becomes a crucial, non-negotiable component of a robust filtration system. A UV clarifier functions by exposing the pond water to a specific wavelength of ultraviolet light as it passes through a sealed chamber. This intense UVC radiation penetrates the cells of the free-floating algae, irreversibly damaging their DNA and vital functions, thereby preventing them from reproducing. Once sterilized, these microscopic algae clump together and die, becoming large enough to be efficiently captured and removed by the pond's mechanical filter media, thus restoring and maintaining exceptional water clarity. It is vital to understand that the UV clarifier is specifically designed to target single-celled floating algae and is generally ineffective against filamentous or string algae, which attach to the pond's surfaces. Beyond algae control, the UV unit acts as a sterilizer, significantly reducing the populations of harmful waterborne pathogens, bacteria, and parasites. This dual action of controlling green water and minimizing the risk of disease is invaluable for preserving the health and visibility of a prized koi collection, especially considering the elevated biological load that requires filter oversizing. The clarifier is typically placed in line within the system, often after the pump in a pump-fed setup or after the main filter in a gravity-fed setup, to ensure it processes the water just before it returns to the pond. Installation and placement best practices for optimal filter performance. Achieving optimal performance from a koi pond filter system relies heavily on correct installation and strategic placement, particularly given the necessity of filter oversizing for high-load koi environments. A foundational best practice is to ensure the filter system is conservatively sized to handle at least double the actual pond volume, a critical factor for maintaining crystal clear water and exceptional fish health. The physical placement of the filtration unit is a direct factor in system efficiency. Filters should be situated as close to the pond edge as possible to minimize the length of plumbing runs. Shorter pipe runs directly reduce dynamic head loss, thereby easing the burden on the pump and maximizing the actual flow rate delivered to the filter. Concurrently, the placement must allow ample and easy access for routine maintenance, backwashing, and cleaning. Positioning a pump at the deepest point of the pond is the ideal strategy for capturing sinking solid waste before it can decompose, while the incorporation of a dedicated skimmer efficiently removes floating debris like leaves and uneaten food. Plumbing is paramount for minimizing friction loss, often the silent killer of a pump's efficiency. Best practice dictates using larger diameter pipework for all runs, particularly the pressurized line from the pump to the filter, which should be a minimum of 1.5 to 2 inches to mitigate flow rate reduction caused by friction.
Additionally, the design should incorporate the fewest possible elbows and bends, as each one significantly adds to the total head loss, restricting flow. It is also highly recommended to use quick-release fittings and valves within the plumbing circuit to simplify the maintenance process. Ensuring the necessary regular cleaning of mechanical media is not a burdensome task. Adhering to these placement and plumbing principles ensures the entire filter system operates near its peak rated capacity, providing the swift turnover and robust mechanical to biological processing essential for a thriving koi pond. Routines and best practices for effective filter maintenance and cleaning. Effective filter maintenance is a crucial discipline for a thriving koi pond, requiring a targeted, dual-pronged approach for the mechanical and biological components. The frequency of maintenance should be dictated by a daily visual inspection of the system, checking for optimal flow rates and listening for any irregular pump noise, which often signals a restriction or clog. Mechanical filtration media, such as filter brushes, mats, or sponges, requires the most frequent attention, often a weekly rinse or even more frequently during peak feeding and warm summer months. This aggressive cleaning is necessary to prevent the accumulation of sludge, which reduces the effective surface area for solid waste capture and eventually starves the biological stage of oxygen. The golden rule for cleaning all media is to never use chlorinated tap water, as it will instantly kill the beneficial nitrifying bacteria colony. Instead, always rinse the mechanical media, gently removing accumulated debris using water that has been drained from the pond during a partial water change. Many modern filters incorporate internal backwash or agitation systems to make this routine less burdensome. Conversely, biological media, including bioballs, ceramic rings, or filter pads, should be disturbed as little as possible. The goal is to maintain the biofilm layer, the heart of the pond's nitrogen cycle. Over-cleaning biological media is a common and damaging mistake. When cleaning is necessary, usually only a few times a year or during a seasonal deep clean, it should involve a gentle agitation or rinsing in a bucket of dechlorinated or pond water to remove loose, heavy sludge that may be hindering oxygen flow to the bacteria. Never scrub the biological media. By adhering to this routine of frequent mechanical cleaning and minimal biological disturbance, the filter system remains balanced, performing its essential function of robust mechanical capture and stable biological processing. Troubleshooting common koi pond filtration problems, low flow, cloudy water, and clogs. Even with a robust filtration system and a diligent maintenance routine, pond owners may occasionally encounter performance issues that require immediate troubleshooting. The three most common filtration problems, low flow, cloudy water, and clogs, often signal a need for mechanical intervention, keeping the core biological components safe. Low flow is perhaps the most frequent operational concern and is almost always a sign of a blockage in the mechanical pathway. The first point of inspection should be the pump itself, checking the inlet cage or screen for heavy debris, as well as the filter's inlet and outlet pipes for obstructions or kinks. In external filter systems, severely compacted mechanical media, such as filter pads or brushes, will slow water passage dramatically. If the flow rate is diminished, an immediate backwash or a manual clean of the mechanical pre-filter stage is necessary to restore proper circulation. A secondary cause can be an insufficient pond water level, which causes the pump to struggle or draw air. Clogs in a koi pond system typically occur where debris accumulation is highest: the skimmer basket, the pump pre-filter, and the mechanical filter stage. Large volume clogs can restrict flow entirely, placing strain on the pump and causing water to bypass the filtration media. Addressing a clog involves physically removing the accumulated organic sludge from the initial stages of filtration. If the clog is persistent and widespread, it can indicate that the pond's filter is undersized for the current fish load or debris level, necessitating more frequent mechanical cleaning. Cloudy water, while sometimes a water chemistry or algae issue, is frequently a sign of inadequate mechanical filtration, a bacterial bloom, or a disturbance to the biological balance. If the water is murky with fine particulate matter, It means the mechanical filter is either clogged, preventing proper capture, or the media is no longer fine enough to capture the smaller suspended debris. Critically, if the biological media has been recently cleaned aggressively, the resulting new pond syndrome or bacterial bloom will cause a milky cloudiness. In this scenario, the mechanical stage should be cleaned to remove excess nutrient-rich sludge, but the biological stage must be left completely alone to allow the beneficial bacteria to recover and reestablish equilibrium. Addressing cloudy water involves patience for biological recovery or an upgrade to finer mechanical filtration media. Effective koi pond filtration relies on vigilance against common issues like diminished flow, clogs, and cloudy water. Reduced circulation is primarily due to compacted mechanical media, obstructions, or insufficient water levels, necessitating immediate backwash or manual cleaning. Clogs typically form in the skimmer or pre-filter and must be physically removed. Persistent clogs may signal an undersized filter. Cloudy water indicates mechanical inadequacy or a biological imbalance.
While mechanical filtration should be cleaned to remove fine particulates, a bacterial bloom demands that the biological media be left entirely alone for recovery. Regular maintenance, focused on the mechanical stages and flow integrity, is key to maintaining proper circulation and a stable aquatic environment.